Hello everyone, welcome to Code and Learn. In this video, we are going to discuss about the Dutch partition problem, or simply known as the Dutch flag problem. The Dutch national flag problem is a common interview question. The flag of Netherlands consists of three colors, that is red, white and blue. In this problem, you will be given an array and a pivot. You would have to group the elements less than the pivot to the front of the array, followed by elements equal to the pivot, and at last, elements greater than a pivot. So something like this, where we are given an array with three numbers, that is 10, 20, 30, and these are the only numbers in the array. There are duplicates as well. So we need to arrange them such that 10 goes to the front like this, 20 in the middle, and followed by 30. Another variant of this problem is that given an array nums with n objects colored red, white and blue, sort them in place so that objects of same color are adjacent to each other, and the order of color is red, white and blue like we have here. You will be given three numbers like we have here to represent the red, white and blue respectively. Here 10 is representing red, 20 is representing white and 30 blue. The partitioning that we learn through this problem will help us understand quicksort, which is a sorting algorithm. So there are different approaches to solve this. An easier approach could be using two-pass approach over the array. In the first iteration, like we did with the even-odd question, we could have two iterators. So we can start from the front. In the first pass, what we will do is everything that is less than the pivot, which in our case will be the middle element, which is 20, will be moved to the front. So I can check here the value is already less than 20. We can move both the iterator and the less iterator to the next element. Now in the next iteration, we see that this is equal to 20. This is not something we want. So we will keep less here so that the next less element that we find in the array can be moved to here. Then we move iterator to the next element. Now this is 30, which is greater than 20. So we don't care and move on to the next element. Again, it is 20, which is equal, but we are looking for the less than element. Again 30. So now we have 10, which is less than 20. So we can swap it to the value at the less pointer. So as you can see, 10 is moved to the front and 20 goes to the back. Since we have reached the end of the array, we can stop the iteration. So in the second pass, we can move iterator to 30 because we already know the first two elements are 10. Since the greater values are to be pushed to the back of the array, we can start the greater iterator from the back. We check again, this value is greater than 20, so this can be moved to the back. The swap has been performed. As such, we can move greater to the left and then the iterator to the next as well. At this point, we have 20. We don't care about 20 since it's less than equal to the pivot, which is 20 in our case. Then we move on to the next iteration. As you can see, both the pointers are now colliding. As such, we can stop the iteration. So the ending array you can see is what we expect. That is 10, 10, 20, 20, 30, 30. So this is the grouping we need. We can optimize the solution further. So instead of performing two passes of the array, we can do it in one pass. Let's see how this is done. For the one pass approach, we will have three pointers or three iterators, that is smaller, equal and larger. We will use equal to move through the array. So at the start of each iteration, we will compare the value at the equal iterator. Since the value that we have is 10, which is less than 20, we perform a swap with the small iterator. Since they are both at the same position, this swap means nothing. And then we increase the pointers to the next element. Now this value is 20. Since this value is 20, which is equal to our pivot, we assume this is at the right position. In that case, we'll just increase the equal iterator. Now this value is 30, which is greater than the pivot. So we will swap it with the larger iterator. And once the swap is performed, we move larger to the left. Now we check the value again at equal. Since this is less than the pivot or 10, we can perform the swap with the smaller iterator. And then we increase both the equal and smaller. Now we check the value at equal again. This is equal to the pivot, so we don't do anything besides incrementing the equal iterator. At this point, equal and larger collide. That means we are done with our iteration. And at the end, as you can see, we have the array grouped. That is 10, 10, 20, 20, 30, 30, which is what we want. Now let us look at the code solution for this. So I'm just going to call this function Dutch partition, which takes an int array and returns the int array. You can also accept a second argument, which is the pivot index. For this problem, we are assuming the array only consists of values 1, 2, and 3. We will say the pivot in this case is 2. Now, we will initialize the smaller, equal, and greater iterators. So smaller and equal, both are at 0. And the greater iterator starts from the end, which is len num -1. Now let's start the loop. This loop is used to perform the pass over the array. We will say equal, less than equal to, greater. If nums or the number at equal iterator is less than the pivot, we need to perform a swap with the smaller number, that is at the smaller iterator. So we can say nums smaller, nums equal. To perform the swap, we just say nums equal nums smaller, and then we just increment the equal and the smaller iterator, just like we saw in our example. Otherwise, we check if number at the equal iterator is equal to the pivot, we are going to increment the equal iterator because we are assuming it is at the correct position. Then the third case is when nums equal is greater than the pivot. In that case, we perform a swap with the greater iterator. So I can say nums greater, nums equal, perform the swap, nums equal, then nums greater. In this case, we just decrease the greater index. At the end, we are just going to return the nums array. So that's the solution for the Dutch partitioning problem. Now let us analyze the time and space complexity for this problem. Since we are only iterating over the array once, the time complexity of this solution is O of n, where n is the number of elements in the array, and we are not using any external space, so the space complexity is constant, which is O of 1. So that's it for the solution. I hope you enjoyed the video. If you have any questions, please reach out to our Discord server or post a comment under the video. Until next time, happy coding!